This example, we already have assumed I1, I2, I3, I4, I5 as the current components in various branches. I1 is the current component in branch AB, I2 in BC, BE, I3 is the current from B to C, and I4 is the current from C, E, and I5 is the current in branch DC. It's your wish to consider the current component direction, but among the current components, consider one as the incoming current component and one at least as the outgoing component. Remaining current directions, they are your wish. Now doing so, and we are going to express those values of I1, I2 and so on, I3 as the functions of the node voltages V1, V2, V3 and so on. So let us write the expression for I1. I1 is the current starting from A going towards B. Current flows from high potential to low potential. If the direction of the current is like this, which means the potential at A is high, the potential at B is low. So this side the potential is 10 volts plus 10 volts. The other side of the resistor is, we don't know them, we assumed that as V1. So 10 minus V1 by I. What is this? I is equal to 10 minus V1 by I. That is the current expression. So because we know I is equal to difference in voltage by resistance value. I is equal to V by R. So coming to I2, the current is flowing from B towards E, which means B should be at high potential. B is assumed as a high potential point and E is at low potential. So current flows from high potential to low potential. That is the direction of this current component is like this, means it is my assumption that this is at high potential, this is at low potential. Later, in the later stage, I may be wrong, right? By seeing the values of I2, I have to decide whether the actual current direction is from B to E or from E to B. But as of now, according to me, uh, I considered the current direction from B to E. So I2 is equals to one side of this resistor is at point B, which is at high potential V1. The other side is at 0. So V1 minus 0 by 4. So I is equal to difference in voltage by resistance, right? So uh, similarly, I3 is direction like this, which is one side is V1, the other side is V2. So V1 minus V2 by 2, that is I3. I4, the voltage drop at this point with respect to reference node is V2. So means one side of this 5 ohms is V2. I4 is equal to V2 minus 0 by 5. I is equal to difference in voltage by resistance. Now I5 is flowing from D towards C, which means D is assumed as high potential point and C is assumed as low potential node, right? So the voltage drop at this D with respect to this E is 15 volts, and the voltage drop at this point with respect to E is V2. So we can write the expression for I5 as 15 minus V2. One side is 15, the other side is V2. So 15 minus V2 by 3, because current flows from high potential to low potential, right? Remember, the current flows from high potential to low potential, right? So now we are going to apply Now we are going to apply KCL at node B. We apply KCL only at the principal nodes. Okay, I1 is the incoming current, I2 is the outgoing current, I3 is the outgoing current. So according to Kirchhoff's current law, the algebraic sum of the currents at a particular node is equal to 0, which means entering currents is equal to leaving currents. I1 is an entering current, I2 and I3 are outgoing current. So I1 is equals to I2 plus I3. We know the value of I1, so put the value of I1 in place of this. Similarly I2, similarly I3. We got an equation which is a function of V1, V2 and so on. Now we are going to apply KCL at node C. Now observe this node C. At this node C, I3 is coming, I5 is incoming and I4 is outgoing. So applying KCL at node C, we get I3 plus I5 is equal to I4. Write the equation for I4 here, the value of I4 here, and I3 here, I5 here, and this entire equation got converted into a function of voltages V1 and V2. Now, solving the equations, we will get uh, the first equation and second equation will get the values of V1 and V2. V1 as 8.24 and V2 as 8.82. Solve these two equations. You may use Kramer's rule or else you may use elimination method. We can use these results to find the other quantities like current and power. For example, we already are aware of I1 is equal to 10 minus V1 by 1. So I1 is equal to 10 minus V1 by 1. So what is the value of V1? 8.24. 10 minus 8.24 by 1. That is 1.76 amperes. So means the current that is flowing through this 1 ohm resistor is 1.76 amperes. The power consumed, we know the power P is equal to VI, I square R, V square by R. Like that, there are varieties of equations are there, a formula are there to calculate the power delivered to the specific component. So P is equals to power P1, power delivered to 1 ohm resistor is equal to current through 1 ohm resistor square into RAB. What is this RAB? RAB is the resistance between A and B. So that is 1 ohm. So we'll get 3.09 unit of power is watt. So like this, we can able to find the other parameter values just by knowing the unknowns V1, voltages V1, V2 and so on. So understand, let us understand a little more thoroughly the nodal analysis technique little more thoroughly by applying this knowledge on the next example, that is having more number of current sources. This is the constant current source. This is another constant current source. We understand this in the next part of this video. Thank you.